Hello everyone, today we will present about DNA fingernail in forensic with evidence collected from fingernails can assist forensic investigation. This review is based on our main journal which explains how fingernails act as a hidden DNA reservoir and why their interpretation must be handled carefully. So, what is fingernail DNA evidence? Fingernail DNA evidence refers to genetic material collected from the area underneath the fingernail known as a subungual space. According to the journal, this area acts as a semi-protected DNA reservoir. This means it can trap and preserve biological materials such as skin cell, blood cell, tissue fragment, and environmental debris containing DNA. So, why is this important in forensic investigation? Fingernail DNA is especially useful because it can reveal physical contact between individual and attacker. For example, during violent struggle, a victim may scratch the attacker. When this happens, the attacker's skin cell can become trapped underneath the victim's fingernails. This evidence can help forensic investigators identify suspects, reconstruct physical struggle, provide evidence when fingerprints are absent, and assist in post-mortem identification. This journal highlights that fingernail evidence is commonly collected in homicide and assault investigation because it may preserve DNA even when other biological evidence is missing. The journal explained that DNA remains trapped because of the unique structure of the subungual region. This area is narrow, semi-enclosed, protected from friction, and difficult to clean completely. Because of this structure, DNA may remain detectable even after hand washing, water exposure, daily activities, and environmental contamination. Research discussed in this journal show that foreign DNA can still persist even after water submersion. This makes fingernail particularly useful in post-mortem investigation, including cases involving decomposition or water-related disaster. To understand this better, let us consider a simple video forensic case scenario.
In 1972, a 20-year-old nurse was murdered in Washington state. The case stayed cold for 49 years. Jody Loomis was walking near the Snoqualmie River when someone attacked her. She fought back hard. Her body was found the next day. Police collected evidence from under her fingernails where she had scratched her killer. But DNA testing wouldn't be invented for another decade. All they could do was preserve the biological evidence and hope. The sample went into storage. Years turned into decades. Technology evolved from basic blood typing to advanced genetic analysis. Jody's evidence sat waiting through it all. In 2021, investigators finally had the tools they needed. They sent the preserved DNA to a genetic genealogy lab. The results pointed to Terrence Miller. He had died in 1994, never knowing how close science was getting. 49 years between the crime and the answer, one of the longest waits in forensic history. Jody's final moments of fighting back preserved her killer's identity across half a century of scientific progress.
This case shows that fingernail DNA can act as a silent witness. Even after many years, the DNA remained preserved and was later used to identify the killer. This proves that fingernail DNA is very valuable in forensic investigation. This evidence is unique for three main reasons. First, it is a hidden DNA sources. DNA becomes trapped in a protected area and is not easily removed. Second, it can survive decomposition and environmental exposure better than many other biological samples. Third, it remains useful even when other evidence is absent, such as when fingerprints are missing, CCTV is unavailable, or body is decomposed. However, there are also explained several important challenges. The first challenge is contamination risk. DNA may come from normal daily contact rather than criminal activity. The second challenge is mixed DNA profile. The journal states that mixed profiles are actually common beneath fingernail and should be expected. The third challenge is secondary transfer, where DNA may transfer indirectly through shared object or contact with another person. The final challenge is low DNA quantity. Sometimes only very small amount of DNA are recovered, producing incomplete or weak profile. Because of this limitation, fingernail DNA must always be interpreted carefully.
Forensic collection method: clipping. Clipping. It eliminates keratin captured, mechanically traps historical debris, and it has time-integrated contact log. Scraping. Scraping. Subungual bed acclimation. It gathers loose cellular pores on the nail plate and collects friction residues. Swabbing. Swabbing. A superficial boundary. It targets surface-associated DNA debris and reflects highly recent touch. Laboratory analysis workflow. The extraction bottleneck. DNA extraction. It has standard purification workflow, inherently discard precious cells. It divesting for low template, highly compromised traces. For stochastic profiling effects of PCR amplification and STR profiling, it has low copy target numbers, triggers extreme molecular peak noise. It induces reverse peak imbalance and allelic dropout artifact. The subungual reservoir. Anatomy versus temporal decay. The figure shows of the cross-section of anatomy of the nails. The keratin shields anatomical shelters protect trapped cells from routine washing, while the curve shows that the temporal curves of offenders DNA rapidly degrades and blends into general background DNA. Laboratory challenges are heavily compounded by the biological and environmental reality of the hand. Research shows fingernails often preserve foreign DNA because the keratin shield formed by the hard matrix and the structural seal of the hyponicum, protects trapped biological materials from daily removal processes like routine hand washing. However, this reservoir has major environmental limitation. The semi-enclosed sublingual space readily traps sweat and moisture, accelerating environmental exposure that rapidly breaks down cellular material. This exposure ensures the DNA molecules leaving forensic analysts to interpret highly degraded partial DNA profiles where key genetic markers have vanished. Comparative reliability metrics. This leads to a final comparative evaluation of reliability. When contrasted with high-template body fluids like blood or saliva, or highly transient open system like touch DNA on skin, subungual evidence present unique activity level complexity. So, is fingernail DNA inherently stronger evidence than surface touch DNA? Biologically, yes. The subungual space protect and retain cells longer, but interpretatively, no. It acts as an ongoing repository for everyone we touch, meaning its present proof a generalized history of contact, not a specific criminal act.
The first approach focuses on the activity level framework, which compares two competing propositions. The prosecution proposition, or HP, suggests that the DNA was transferred during a violent struggle, while the defense proposition, or HD, argues that the DNA may have accumulated through innocent social contact, cohabitation, or secondary transfer. The journal also highlights several scientific variables that influence interpretation. First is background prevalence, meaning individuals may already carry foreign DNA beneath their fingernails from routine daily contact. Now, I will discuss option 2, which is combining fingernail DNA with other forensic evidence. The journal strongly emphasized that fingernail DNA should never stand alone. It should act as context-amplifying evidence rather than context-defining evidence. For example, if investigators claim a violent scratching event happened, there should also be supporting physical findings, such as linear abrasions, defensive wounds, or injury patterns. If DNA is present but there are no related injuries, then accidental transfer becomes more plausible. The paper also suggests multidisciplinary profiling. Besides skin cells, the subungual region can trap other materials like drug residues, toxicological traces, isotopes, and even gunshot residue particles. Interestingly, studies show that the gunshot residue can remain trapped under fingernails even after hand washing because the subungual area is relatively protected. Lastly, option 3, which involves advanced sequencing technologies and hybrid forensic strategies. The journal explains that forensic laboratories are moving toward more advanced collection systems, such as wet vacuum devices and optimized chemical formulations, to recover low-level DNA more effectively. Another important improvement is direct amplification. Traditional extraction methods can cause sample loss, especially for low-template DNA. The paper also discussed probabilistic genotyping software like STR-mix and Bayesian modeling. This system mathematically calculates the likelihood of DNA mixtures while considering transfer probability degradation, stochastic effects, and background DNA. This approach is more reliable because it reduces subjective interpretation and focuses on statistical evaluation instead. So overall, after evaluating all the approaches, the most practical forensic strategy is not relying on fingernail DNA alone. Instead, fingernail STR profiling should be supported with other forensic evidence. To sum up, this journal changed the traditional perspective of fingernail DNA evidence. Rather than treating fingernails as direct proof of assault, forensic scientists should recognize them as biological reservoirs that continuously collect DNA over time. Therefore, interpretation must be cautious, activity level based, and supported by multiple forms of evidence to avoid overestimating the significance of the findings.
Based on UNCIT's P2026 review, one of the most important recommendations is immediate evidence collection. The journal explains that DNA transferred during defensive scratching is easiest to detect right after contact. However, this offender DNA decreases rapidly within 3 to 6 hours and may become undetectable after 12 to 24 hours. At the same time, normal background DNA from daily activities such as touching objects, washing hands, or grooming can replace or mask the original DNA. Therefore, forensic teams must collect fingernail samples as soon as possible and accurately record the type of collection. The journal also highlights the need to improve laboratory methods. DNA under fingernails usually exists in very small amounts, known as low-template DNA. Unfortunately, standard extraction methods may accidentally lose part of this valuable genetic material. To improve DNA recovery, Academy recommends combining subungual swabbing, nail clippings, and direct DNA amplification. In addition, forensic analysts should avoid cognitive bias. They should not be influenced by unnecessary case details such as visible injuries because scientific interpretation must remain objective. But does finding DNA under fingernails automatically prove a struggle? Not necessarily. According to the journal, forensic scientists should move beyond simply identifying whose DNA is present. They must also evaluate how and when the DNA was deposited. Catby explains that DNA can be transferred through direct scratching, indirect skin contacts, or even shared objects. This means the presence of someone's DNA under fingernails does not automatically confirm assault. Instead, scientists should use activity-level interpretation and probabilistic models to compare different possible explanations. In conclusion, the journal described fingernails as time-integrated DNA reservoirs. This means they can collect and retain DNA from multiple sources over time, including normal daily contact. Because mixed DNA and background DNA are common, dominant DNA under the fingernails should not automatically be interpreted as proof of assault. The true value of fingernail DNA lies in careful scientific interpretation supported by proper timing, laboratory analysis, and activity-level reasoning. Overall, fingernail DNA can provide important forensic clues, but only when its complexity is understood and interpreted with scientific caution.